Very good morning, students. Our next topic is designing a multiplexer circuit. So to design a multiplexer, first we need to know what is a multiplexer and what are the different applications of this multiplexer. Okay, so multiplexer is otherwise called as MUX, M-U-X. So this is a symbol for MUX. Multiplexer is otherwise called as MUX. Multiplexer is also called as many to one. It will have several inputs, many inputs and single output. So you need to understand multiplexer is a device which will have multiple inputs, single output. That is why we call it as many to one. So multiplexer is a device which selects one out of several inputs. So this device will select one input out of several inputs and forward that input to the output. So what is the job of multiplexer, or the objective of multiplexer? Is it selects one input out of several inputs and forward that input to the output. Okay, let us see the block diagram for this multiplexer. So this is a multiplexer. What type of multiplexer it is? N:1 multiplexer. What is N? N is number of inputs. What is this 1? 1 is output. So number of inputs is to output multiplexer. N:1 multiplexer. I have n inputs, 1 output. In this case, can you see how many inputs I have? 4 inputs. And only 1 output. I can call it as 4/1 multiplexer. N number is 4 here. So it is 4:1 multiplexer. See this application of a multiplexer. This multiplexer is connected to 4 inputs. One is connected to MP3 player, other one is to laptop, third input is to digital satellite, and fourth input is to digital cable TV. So what is the job of multiplexer? It needs to select one of the input and forward that selected input to the output. So to select that one input, we need to have something called select lines. So select lines are very important. This select lines will decide which input I need to select and forward to the output. So multiplexer will have inputs, outputs and select lines to select the input that has to be forwarded to output. Let us see the first case, designing a 2/1 multiplexer. That means 2 inputs, 1 output multiplexer, or MUX. So this is the block diagram to design a 2/1 multiplexer. I have 2 inputs, so I have designated them as I0 and I1. One output, I have designated them as Y. Now I know that I need to understand how many select lines I need to have. So what is missing here? Select lines. The formula to identify number of select lines is number of select lines is equal to 2 to the power of m is equal to 2. So m is the one which tells number of select lines. N tells number of inputs. So in this case, number of inputs is 2. I0, I1. So n value is 2. So number of inputs is 2. So number of select lines is equal to 2 per m. 2 per m is equal to what? N. N is nothing but 2. So 2 is nothing but 2/1 is 2. So m value is equal to 1. So number of select lines is 1. So I have written one select line and termed it as S0. Okay. So 2 inputs I0, I1, 1 output Y. For 2 inputs, I should have one select line based on this formula. 2 per m is equal to n. Now this is the diagram which we have seen. Now the next step is I need to draw the truth table. Since I have one select line S0, that select line can be either 0 or 1. If the select line is 0, select I0. If the select line is 0, select I0 and forward it to the output. If the select line is 1, select I1 and forward it to the output. So my truth table will have select line and Y output. So if it is 0, I need to forward I0 to output. If it is 1, I need to forward I1 to output. So you know 0 is S bar, 1 is S0. Sorry, 0 is S0, 1 is 0 is S naught bar, 1 is S naught. Okay. Now let us write the logical expression for Y. When I get Y, what is my Y? Y is S naught bar is I naught plus, can you see S naught bar I naught plus S naught I1. Okay, so I have got my Y. So now draw the logic diagram. Two inputs I naught, I1, one selection line S naught. This is my select line S naught. Now this is my NOT gate. The output is S naught bar. What is my first term? S naught bar I naught. So S naught bar I naught, I am connecting it to a NAND gate, AND gate. Now what is my second term? S naught I1. So I take S naught, I take I1 connected to a AND gate. Two AND gates are connected by OR gate. So two AND gates are connected to OR gate. This is how I obtain my output Y. So now we have seen and designed a 2 by 1 multiplexer where it has two inputs, one output and one selection line. Two inputs, one output and one select lines. Thank you.